You know, in clinical microbiology, some of the most interesting organisms are the ones hiding in plain sight. And today, we're unmasking a big one, Corynebacterium striatum. For years, so many of us just dismissed it as a contaminant. But now, we're realizing it's a seriously formidable pathogen. And in this explainer, we're going to break down exactly why.
This quote really just hits the nail on the head, doesn't it? It perfectly captures this huge challenge we face in the lab. How do you tell the difference between a harmless bug and a dangerous one? Well, with Corynebacterium striatum, that line has gotten incredibly blurry, and our whole understanding has had to change, and fast. So let's dig into that evolution. So here's our game plan for tackling this organism. First, we'll look at how it went from being ignored to being a major threat. Then, we'll head into the lab to see how we can unmask it. After that, we'll check out the clinical impact, figure out our antimicrobial counterattack, and finally, talk about how to stop this thing from spreading.
All right, section 1. So how in the world did this bacterium go from something we just ignored on the bench to a top priority for infection control? Let's find out.
For decades, it was the same old story. A coroniform rod pops up on a plate, especially from something like a skin swab, and what do we think? Contaminant. We just assume it's normal flora that hitched a ride. But while we were all looking the other way, Corynebacterium striatum was quietly setting up shop. But wow, the reality today is completely different. We're now up against a major multi-drug resistant organism, an MDRO, that's causing severe, even life-threatening hospital-acquired infections. And its rise really became obvious during the COVID-19 pandemic. It was a perfect storm, right? You had prolonged ICU stays, intense antibiotic pressure. It was the ideal environment for this bug to absolutely thrive.
Okay, so this brings us right back to the lab. If we've been overlooking it for so long, how do we reliably unmask this culprit now? What are the key things we really need to be looking for?
Well, it all starts with the basics. You look under the microscope and you see those classic gram-positive, pleomorphic, club-shaped rods, the Chinese letters we all know as coryneiforms. But then you get to the blood agar plate, and that's where the trouble starts. The colonies have this moist, whitish-yellow look that is a dead ringer for coag-negative staph, which is exactly why it's been getting missed for so long. And this is where the old-school biochemical tests really struggled. I mean, look at the differences between Corynebacterium striatum and its close relatives. They're so subtle. Yeah, a positive nitrate reduction helps, and so does that pattern of sucrose fermentation without maltose fermentation. But trying to rely on these little nuances with older commercial ID systems, it often just led to really ambiguous, frustrating results. This comparison just perfectly highlights the massive leap forward we've made in diagnostics, where the older systems really had a hard time telling these species apart, which led to missed or delayed diagnoses. Our modern technology just cuts right through all that ambiguity. It gives us the definitive answers we need to actually take clinical action.
And here it is, the diagnostic revolution in action. MALDI-TOF has been an absolute game changer, right? It gives us a species-level ID in minutes flat. And for that ultimate, rock-solid confirmation, gene sequencing of 16 srRNA, or the even more discriminatory RPOB gene, is still our gold standard.
So, we've identified it. What does that actually mean for the patient? Let's connect these lab findings to the really wide range of severe infections that Corynebacterium striatum can cause. The clinical spectrum is broad, and it's almost always something picked up in the hospital. We're talking a major cause of ventilator-associated pneumonia and catheter-related bloodstream infections. We see it in these devastating cases of endocarditis on prosthetic valves and in nasty prosthetic joint infections. The one common thread that connects almost all of these cases, its incredibly powerful attraction to indwelling medical devices. So, what's its secret weapon? It's not some classic powerful toxin. It's this incredibly effective pathogenic triad. Number 1, it is a master at forming biofilms. Number 2, it has tons of surfaces to stick to in modern medicine, all those indwelling devices. And number 3, its multi-drug resistance lets it thrive where other bacteria just get wiped out. This combination makes it perfectly and scarily adapted to our hospitals. So this brings us to our counterattack, antimicrobial therapy. And this is where things get really, really complicated, all thanks to this bug's extensive drug resistance.
Okay, effective therapy all comes down to accurate susceptibility testing, and here are the key clinical breakpoints from EUCAST. Now, notice something really important. For our main weapons, vancomycin, linezolid, and daptomycin, the breakpoint is susceptible increased exposure, or category I. What that's telling us is that we need optimal, high-dose therapy to have a shot at success. And meanwhile, for drugs like Cipro, high rates of resistance are pretty much the norm. So the international consensus is pretty clear. Vancomycin is the go-to drug, with linezolid being a fantastic alternative, especially because you've got that oral option. Daptomycin? You have to be extremely careful because resistance can pop up right in the middle of therapy. Now, in the ditch context, there aren't specific national guidelines, but the approach is the same. Let your AST results be your guide. But, and I can't stress this enough, source control is absolutely non-negotiable. That infected line, that infected prosthesis, it has to come out. Period.
Treating kids is a huge challenge here. Corynebacterium striatum is what we call a therapeutic orphan in pediatrics, meaning there are just no dedicated clinical trials to tell us what to do. We are literally forced to guess, to extrapolate from adult data, and rely on really meticulous weight-based dosing. This means super careful therapeutic drug monitoring for vancomycin and age-dependent dosing for linezolid. It's a massive knowledge gap, and it's one that really needs our attention.
And finally, our fight against Corynebacterium striatum doesn't stop with just one patient. We have to contain its spread across the entire healthcare environment. And that means robust infection prevention and control. The core strategy here is comprehensive, but it's built on pillars we all know. It starts with the single most effective thing we can do: meticulous hand hygiene. For known cases, you need strict contact precautions, and because this bug loves to stick to surfaces, thorough environmental disinfection is critical. The lab's role in surveillance, spotting and reporting clusters early, is absolutely key, and all of this has to be backed up by a strong antimicrobial stewardship program.
So as we wrap things up here, it's really worth taking a moment to just think, how does all of this actually impact our day-to-day work in the lab and how we talk with our clinical teams?
Okay, let's boil it all down to 4 absolutely critical takeaways. Number 1, shift your mindset. This is a real pathogen, not just a contaminant. 2, identify it right. Use modern tools like MALDI-TOF. 3, treat it smart. That means AST-guided therapy with vancomycin or lenolinezold, and always prioritizing source control. And finally, number 4, contain it strictly. Treat it with the same respect and rigor you'd apply to MRSA or VRE.
This explainer, by the way, was all compiled using a Gemini deep search, and you can dive into the full list of sources in the linked notebook document. If you found this deep dive helpful, please subscribe for more explainers on emerging pathogens. We would love to build a community around this, so please share your feedback and any local protocols you might use for managing Corynebacterium striatum down in the comments below. Thanks for joining us.